So we're going to give you a quick overview and then jump into 3 demos. So I'm going to go kind of fast and just lay some groundwork, paint a broad picture, and then we can get questions at the end. So Message Analyzer is the sort of follow-on to Netmon, eventual successor, still a work in progress. We released it with the same time as Windows 8.1, and let's see, about three or so years ago, we realized that we needed to kind of reboot Netmon, and we wanted to take a different approach to enable a new category of diagnostic scenarios. And so rather than just trying to parse and display, we wanted to actually model protocols and interactions and create, sort of formal specifications and allow you to characterize constraints on packets that are sent or particular field values and characterize what are good sequences and good interchange patterns. And so what we've ended up with is a world where we have a new notation. We call it OPN. It replaces NPL, and this lets us actually create real models of protocols and characterize their data formats, how they're encoded, their constraints, their interactions, their architectural layering with other protocols. And by taking one specification and one implementation, we can then do some interesting things, as you see in the slide. We can test conformance and compliance. We can do diagnostic analysis. We can also generate code contracts. We can generate protocol documentation, which is something that Microsoft does a lot of now. And we generate templates of documentation automatically from the models. And then we do the analysis, which is what we're going to walk through here. We tend to think of analysis as fitting into kind of 3 activities. One is data collection, which can either be live tracing or loading of existing data. Then you do analysis to try and figure out what your problems are. And in that process, you might create artifacts that will start to show you that help facilitate the analysis, let you define new patterns of things you're looking for or new color rules to highlight things. And then you can share those with other people, teammates, coworkers, communities, so that people who are trying to find similar kinds of problems can build on the work that you've done. So just drilling into those real quickly. On the tracing, we've expanded what Netmon did, where we just took basically raw Ethernet packets and processed them in a parallel stack. And that has a lot of power and advantage, but it also tends to be slow sometimes. So we've extended that to actually allow you to come in at different layers. By having formal models of every protocol, we can take packets anywhere and just pick up and process. So if we have an Ethernet packet, we can start Ethernet. If it turns out we're hooked up to a firewall and we have IP packets, we can just start right there. This has the advantage of being after IPsec decryption, so we don't have to worry about that. Similarly, we can intercept at a web proxy, get above HTTPS, and we don't have to worry about TCP reassembly and all that. So the idea was to make this configurable, let you start from anywhere that you want. And we also formalized the ETW processing. So in Netmon, we kind of had a ad hoc way of loading some ETW. With Message Analyzer, we'll take any manifest, infer a model from that automatically, and then start parsing the traffic or the events immediately. Other data sources that we take from are the system event logs.
I saw there bullet number 3, capture loopback traffic.
Yeah.
Please repeat that.
The question was on loopback traffic. Yeah, We have an ETW provider that hooks into the firewall interception point, so we can catch loopback traffic, whereas with Netmon it was harder because it was on the NDIS stack. So this is actually, if you fire a loopback traffic, we'll intercept it at the firewall level, and we can capture it that way. Is that?
You'll be able to capture it all loopback, right? There's no limitation on each other, right?
Yeah, all loopback. Let's see. So system event logs. We also have very rich text log processing. So a lot of the data is written out with printf statements to text files. We let you shred text files and other formats. And then with 8.1, we've introduced the capability of being able to remotely capture network packets and ETW events. So you can point message analyzer at an 8.1 system and configure the NDIS driver on that machine to intercept at some different points and identify some ETW providers that you want and pull that data remotely, and you can also truncate it at a certain packet size if you want. In terms of analysis, we kind of break that into two aspects. One is we're trying to make it easier for the human to figure out patterns in data. So we have a bunch of features which you'll see that allow you to take your data and slice it and carve it and shape it in different ways and then view it using different representations. We also have, because we have models, we can effectively simulate your models with the data. So we can reassemble messages automatically. We can fold them together in operations. So if you have requests and response, we coalesce them together so that you see minimal data traffic. And then you drill in as you need to. We can also look for automatic constraints and pattern violations. So if you know that this is, should be A followed by B followed by C, you can detect whether or not that's actually happening. And then finally, you'll see an example of sharing, where as you're creating artifacts during your analysis, whether they're color rules or pattern descriptions or even new protocols, you can use an RSS feed mechanism or a file share to distribute those to other people who can then essentially listen in on your announcements. And so with that, I'm going to turn it over to Serge, who's going to walk us through 3 demos where we try and figure out some security problems.
Okay. Let me pull up Message Analyzer. So this is the start page of Message Analyzer. So let me quickly walk you through the main components. So in the start page, by the way, this is a live page. So you'll get news, download, updates for parsers, for example, shown here. There is the capture page, and this is basically for doing live capture. So as Chris mentioned, we can capture from any TW provider we find in the system. We have some built-in providers for our own drivers. And we have this list of what we call trace scenarios that try to capture these common capture scenarios. So sometimes there's just one provider. For example, this is the link layer provider. There is our wrapper for the NDIS capture. But there is some other trace scenarios like USB capture, Bluetooth capture, RPC capture, and some of them involve not just one, but many ETW providers. So the idea is that you can populate this list, selecting which sources you want to capture from, and then you can pull that everything together in the same session. So this is for the capture part, and I'm not going to go into much details now. I have some traces here, and this seems to be hanged, by the way.
Excellent. This was planned to show you that this isn't a video.
Yeah, not just screenshots. Okay, now it came back. The other main part of Message Analyzer is the browse page, and this is where you import captures to Message Analyzer. So let me start with the first demo. This first demo is about, let's say that we have this scenario where a customer is complaining, hey, I think I'm having some sort of exploit attack in my system, and here's a capture file. I think that represents what's going on there, but I'm not really sure what's happening. So what I'm going to do is I'm going to import this capture file, and the goal of this demo is let's try to identify what's going on. Let's try to identify the source of this problem. So I'm going to add this capture here. And in this case, I'm using a capture that was saved using MA format. And the main idea of the browse page is you'll get some initial metadata of what your capture, what your traffic looks like, without really pulling all the messages into MA. So the main idea is that you're going to get things like, well, how many messages, what is the start time, the end time. You can narrow down the data using these filters. And for some reason, this is taking a very long time.
Yeah.
OK. It's very slow. So there are basically two ways to initially narrow down the data. There is this time filter, this slider here. And this is basically, let's say that you know that the incident happened at, I don't know, 2 p.m. And you have this big capture file that was running for the whole day. So you can say, well, I'm interested in the messages starting like 1:50 and ending at 2:10. I don't really want to look at the rest. So you can narrow down the traffic you import with this slider. And then you have this filter section. And this looks pretty much like what Netmon had. So if you say, OK, I'm interested in just things whose TCP port is 80, then you write that, and you just import those messages. So this is a very useful way to reduce the footprint. The tool will be snappier. So if you know what's going on already, you can filter it down before you import it. But in this case, I'm going to just leave the capture as is. And so now that I have this metadata, now I really want to look at it. And as Chris mentioned, Message Analyzer has multiple viewers to look at the data. The default viewer is the analysis grid, what is what you see here. This gives you a sort of Netmon-like experience where you see all the messages in a grid. But instead of using that, I'm going to use another viewer that will allow me to have a more higher level overview of what's going on before jumping into too many details. This is what we call the protocol dashboard viewer. So as you can see here with all these bars, you see all the protocols that are present in the capture. And here, the first main difference with Netmon or even Wireshark is that, as Chris mentioned, we have stateful models that represent all these protocols. And that means that all these bars that you are seeing are top-level protocols. That means that we parsed, we reassembled, we put everything together, and we are displaying up to the highest point we understand. And that means that, for example, these UDP bar are really pure UDP messages. They are not being used as a transport for something else. Of course, we always have the case where maybe there are some protocol that Message Analyzer doesn't understand. That's always the case. But if we don't think about that for a second, then these are really top-level protocols. That's the main thing. And then the other thing is that, for example, we can show number of messages across time. You can filter that by protocol type. So with this high-level overview, there is one thing that I can point out almost immediately, is that I have a lot of UDP and TCP traffic there, pure TCP and UDP traffic, which is not the usual case, the most usual case for capture file. UDP and UDP are mainly used as transport protocol. I would expect to have something on top of that. So that's the first sign that there might be something wrong going on. And the other thing is that if you look at this diagram, there is this spike of TCP messages happening in a very particular moment in time. So that could be another sign of, well, maybe this attack happened exactly at that point, and that spike is representing the attack. So I think this is a nice way to start. You don't need to drill into too many details. You get this very high-level overview. The next thing that I think is interesting is that this viewer is interactive. So, for example, if you select one of these bars, And you say, well, now I'm interested in drilling down into this particular set of messages. You can double click on this bar, and that takes you to the grid, and you will only see the messages that are related to that protocol. So what I'm trying to get here is that you have this usage pattern that you start from high level and then you can drill down, which I think is very useful. So let me remove this filter for a second. So now I have like the Netmon-like view, the grid view of the whole capture file. So before jumping into the actual exploit detection, let me quickly walk through the main generalities of the grid. So the first thing is that, well, you see all these columns. This is the default layout. But with the grid, you can add anything as a column. So every field is something that you, for example, you right-click and they say, add this as a column. And you have it there. You can sort on any column, which is pretty useful. As I mentioned, you can filter, and this is a display filter. This looks more or less like Netmon with some enhancements, but it's more or less there. You can say, I just want to see TCP traffic. You apply the filter, and you get the filtered traffic. The other interesting point is that you can pivot on any column that you added. And this is super useful sometimes for understanding what's going on. So for example, I can right-click on module and say, well, group by module. And this gives me a categorization of messages per module. So for example, now I have, similarly to the protocol dashboard, a pretty clear high-level view of what are all the protocols that are present in my capture. And I can also multi-group. For example, I will group by module and source address. So now I have these two levels of grouping. So I can easily see, well, for DHCP, these were the source addresses that were involved in that protocol. So this is a very nice way to pivot data in multiple ways to try to understand what's going on. So that's for the grid. Coming back to the original problem, I have this capture file. I have this suspicion that it's about TCP that happened in a particular moment in time. So the regular way, the usual way of diagnosing this is, well, I can start grouping, filtering, drilling down this data. But if you think about it, what you're really trying to do is to discover a pattern, a well-known pattern. Usually troubleshooting is about discovering these patterns. So what we added in Message Analyzer is what we call sequence expressions. And you can think in sequence expressions as filters, but instead of talking about particular messages, so with a filter you say TCP port equals 80, and that applies to one message. What you can do with this is to describe a pattern that spans across a sequence of messages. So the language to describe this looks like a BNF-like language with captures. So think that you can say things like, well, the first message I want to see is a message A, followed by an arbitrary number of Bs, and then eventually a C. And all these messages need to have the same source address. So that's the type of pattern you can describe. So the idea is that let's try to use that to see if that can help us identify what is the particular exploit attack we have there. So let me launch the sequence match viewer, and this is just another viewer. So when I launch this, the ribbon changes, and now I have this sequence expression button over here. So these are some sequence expressions that are shipped together with MA. But now I want this particular exploit-related sequence expressions. So maybe I can write it myself. So here you can right-click, add your own sequences. But of course, you need to know the language, and you need to know what you're doing. So here is where I'm going to make use of this sharing infrastructure that Chris mentioned. And the idea is maybe I'm not an expert in sequence expressions, but maybe somebody else from my community is. And he has this feed where he publishes these artifacts that helps me diagnosing my problems. So what I'm going to do is I'm going to connect to that feed and try to see if there is anything there that can help me. So let me go back to the start page. I'm going to go to settings. And here is where I see all the feeds I'm following. For now, I'm just following one feed that is the official MA feed where, for example, parser updates, news, things like that come. But what I'm going to do is I'm going to add a new feed. And I have, this is just a short folder that I have here. But imagine that this feed may come from a forum, from an email, from who knows. So I'm going to add that feed. let's call this search stuff. So now I'm following this feed. So now I can go to downloads. Here I see all the artifacts that are being shared through all the feeds I'm following, but I can filter by the incoming feed. So when I go to search, I see these 3 artifacts that are being shared. And well, because I'm super lucky today, I find that there is an exploit attack package there that says this is a set of sequence expressions to detect exploit attacks, which is something that I can really make use of today. So what I'm going to do is I'm going to download and say, yes, I want to import these artifacts, and also let me know if there is any update coming. So here I uploaded that. So let me go back to the home page. So here, if I click on sequence expressions, you will see that under search, there is this bunch of sequence expressions that one identifies TCP SYN flaw, the other one a bandwidth attack, the other port scanning exploit attack. So those are the sequence expressions that were imported. So first, let me put this side by side. And by the way, all the windows are dockable. So now I have this side-by-side view, the grid on one side, the sequence expression viewer on the other. And since I'm not really sure what's going on, what I'm going to do is I'm going to turn on all the sequences to see if there's anyone that says, yes, I understand what's going on. So now the sequence engine is running. And let's give this a second. Here it goes. So there is one sequence expression that says, yes, I can recognize this pattern. And the sequence expression is a port scanning exploit attack. So this is sort of a confirmation that, well, there is a port scanning exploit attack going on. This sequence expression understood what was going on. And when I expand that, I see all the messages that were involved in that pattern. And the nice thing is that if I click on the match, on the other side, in the grid view, I get all the messages that are part of this attack highlighted. So now I can easily understand the details of that attack. And for example, I can go and look to the source column and say, OK, now I understand that this attack is coming from this particular IP. OK, so that's the first demo. Let me jump to the second one.
While you're doing that, one of the things you'll notice in the browse is that we can actually import multiple files. So whereas Netmon was open one file at a time, this message analyzer will allow you to grab as many files as you want, pull them all in together, and then you can combine them, group them, filter them as one.
Yeah, good point. And I think it connects very well to this second demo. And the idea of this is there has been a password guessing brute force attack, and that has been captured, supposedly. But the interesting part is that now I have two capture files that represent this attack. I have a PCAP file that has been captured with Wireshark. This is a network capture, and supposedly that was done during the attack. And I also have an EVTX, a system event file, that represents what happened on the system side at the same moment. So now I have these two sources, the network and the system. And what I want to do here is I want to put them together, first confirm that the attack is really there, and then see if I can correlate the data. So if I can see this set of network events that end up in this system event that represents what happened on the system. So let me import these two things together. So I know I'm going to throw these two things into the same session. I'm going to use the analysis grid now. So now I'm importing the messages. And, well, first of all, what I usually tend to do when I face a new troubleshooting problem is I usually group by module. That is what gives me the first high-level view of what's going on. So here I can see an event log set of messages, which is probably coming from the EVTX file. And then a bunch of other protocols. Probably many of them are just noise. But I see a lot of messages coming from RDP. And that's probably the network capture, the brute force attack coming from an RDP session. But so first what I'm going to do is I'm going to open just the event log bucket to try to see if I can really confirm what's going on. So what I see is, well, a bunch of account failed to log on events. I have around 20 of them coming from the same source. And there is like 3 millisecond difference between the whole thing. So that's probably a very big hint for saying, yeah, well, there has been some sort of brute force password guessing attack. So that's for the first part. But now let's try to correlate the traffic and to put both sources together. So I'm going to remove the grouping. And notice that the context, the highlighted messages, is kept. And that's also very useful because usually what I do is I group, filter, try to find what I'm looking for, select the message, and then remove some of the groupings or the filtering so I get the bigger context with that same message highlighted. So now I can see that thing in the context of a bigger capture. So let me sort by timestamp. So now I'm supposed to see all both sources intermingled together. So probably what I'm seeing here is a lot of RDP traffic that ends up in an event log saying account failed to log on. But here the problem is that I'm not really sure if all this network traffic really belongs to the same conversation. So I'd like to narrow this down a little bit more so I can see, well, this is the traffic that caused this event. So for now, let me pull up a view layout. And view layouts are mainly, as I said, you can add any column to the grid. You can move them around, size them in any way you want. And then you can save that as a column layout that, by the way, you can share, for example, this using the shared infrastructure if you think your layout is useful. But so I have a layout already built for this. And that basically has, well, the timestamp sorted. And it also adds the network and transport columns. So now I can easily see TCP IP conversations. So the first thing that you can see is that I have the source address column that is being populated from both the network traffic and the event log. So that is like the first source of correlation I can find. But let me add another column. And for that, I'm going to use the column chooser. And the column chooser is basically exposing every protocol field that Message Analyzer understands, so I can look for columns and add them. So I'm going to look for source port and add it. So now, and let me put this together with source. So now I have source addresses and source ports there. And observe that the event logs are also populated in the source port. So here I have a very easy way to correlate the data. That is, let me group by source. And then let me group by source port. So now what I have here is all the traffic that was originated from this source port and source address that ended up in the event log that represents the logon failed attempt. So in this way you will find for each of the event logs, they will fall into one of these buckets and you will have the traffic partitioned in that way. So that was the second demo. So let me jump to the last one. And the idea of this one is there is a backdoor installed, a persistence backdoor installed in my system. And I have the EVTX log of that is supposedly representing that. And this backdoor is known to launch the command prompt from a weird process. So the command prompt shows up where it shouldn't show up. So the idea is that, again, let's try to understand if that's the case and try to understand exactly when that happened and what is the process that was responsible for that. So I'm going to create this new session. I'm only going to take the EVTX file and open the analysis grid. So this looks similarly to the event log viewer. So when I click on any message, I can see all the fields. I can see that, for example, these are all logon events. Again, I'm going to sort by module. And let me collapse the group. So, but here I mainly see two things. There is this event log bucket and the event log analysis bucket. And this event log analysis is something I wrote for this case. And I wrote this using OPN, this language that we created, that Chris mentioned. And under event log analysis, what I see are these blue icons. And blue icons are operations. Operations are not real events. They are not defined in any technical document. Operations are just abstractions that we introduced with MA. And operations basically correlate automatically data. They put messages together into the same bucket, so I can easily spot at a high-level view what's going on. And the idea of these operations is, if I drill down, what I say is that these operations are grouping logon events, all the related start process events related to that specific logon event, and potentially a log-off event. So each operation is representing the activity of one particular logged-on user across time, and it's grouping all the start processes and events that happen associated to that particular logon in the same group. So this gives me a very high-level overview of what's going on with this traffic, because I have these 5 different logon attempts that have start process events related to them. The other event logs, the messages that fell into the other bucket, are logged on events that don't have any start process, and that's why they were not grouped, they were left alone. Because for this particular case, what I'm more interested about is to understand the correlation between someone that logs on and then does something there, it starts some real processes. And the other thing that operations can do is that they can aggregate data. So if I click on the operation, I do see some fields there that are computed from the children of the operation. So for example, what I can get here is the process tree that belongs to that particular user, and that process tree is computed from the children of the logon event. So coming back to this particular problem, I'm interested first in identifying what are the start events that correspond to this command prompt launch. So for a moment, let me hide these operations. So I want to get this flat view again of everything. And what I'm doing is I'm going to write a filter to spot those messages. So let me write a filter that is like process name. So the process name of each of the event contains CMD. So when I apply a filter, now what I get is these 3 events that correspond to the command line prompt being launched. But to understand this better, let me pull out another layout that I have that has particular columns there. Okay, here it goes. So this layout brings the parent process name and the process name. And again, this is an automatic correlation that is being done. So looking at the message history, because we have stateful models, we can put parent processes and processes together, so you can easily see that dependency. So from these 3 command start events, I see one whose parent process name is winlogon. And this is exactly the indicator that there is this backdoor going on, because you're not, it's not very typical to see winlogon, the process that runs with Windows starts up, when you have the logon screen there, launching the command prompt. So that's a very good hint that the backdoor is there, and somehow it made winlogon to launch command prompt. But now the nice thing is that now that I identified a problem, I can see this event in the context of a bigger capture. So let me bring back the operations. And now what I can see is the start event in the context of this particular user that logged on. And here I can easily see that the subject username is system. So it was system logging on, launching all these events, and at this point, launching the command line from the winlogon process. Okay, so that was the end of the 3rd demo. And I guess that was everything I had to say.
Wrap up and then open it for questions.
Okay, you want me to do that?
Sure.
I have the 3 demos here just in case you find the slide deck afterwards. Okay, so what I think I showed is Message Analyzer offers you these flexible visualizers, so you can first choose the right level of abstraction you're gonna use. In many cases, you don't want to jump to the very detail at the beginning, and you want to have this more abstract view. I showed that now we simulate protocols, and that means we reassemble everything, we put everything together. I didn't show that specifically, but we put request and response together, like HTTP request response. We can abstract sequences, meaningful sequences, into these higher level entities.
Another thing we didn't show is if you have constraints in your protocol, like this field must be within a certain range, the grid will automatically highlight any message that it found that violated those constraints so that you can see that immediately and jump right to that message. We found that actually very useful in some interoperability testing workshops that we've been in, where people had used Wireshark for a couple hours to hunt down a problem. We opened it up and immediately showed, here's the problem. You know, this value was supposed to be 0 and it wasn't.
Yeah. And well, I also show that with operations and with sequence matching, you can very easily identify known patterns and get the correlations done for you. So these are some resources. If you want to take MA for spin, you can download it from that link over there. We have a forum. You'll find articles, troubleshooting experiences. You can ask questions. There is also an FAQ. So I guess that's it.
Yeah, for internal people, there's a mail alias and there's a installation kit on Toolbox.
Yeah, and for external questions, we mainly use the forum.
Yeah. So with that, any questions?
We have one here. If we can get him a mic first.
If we have an SSL cert, can you decode SSL traffic?
The question is, do we decode SSL traffic? Not with the current shipping version, but it is very high on our list.
Okay, because I use Wireshark mainly for that, and most of the time it doesn't work. Give me that to be really great.
Got it. Working on it.
V next. No one here? Coming?
How much data can the analyzer practically handle?
That is kind of a function of how big your machine is. We've tried to make some trade-offs so that we can handle more data and use less memory. So we page in data as we need it, and we do some interesting caching. One of the things that you saw, I heard people chuckle, but you see the little green bars that are going across. We've tried to parallelize as much of the processing in the UI as we can. So each of the windows actually operates independently of all the other ones, which is when you see the spinning bar going on. So we've tried to make our scale as high as we can. We continue to improve it. I'm not sure that we have any numbers just yet. We've loaded.
And I guess it also depends a lot on the protocol,
on your machine,
the traffic that you load.
Yeah, if you're loading Ethernet frames, it's a lot easier than if you're loading, HTTP frames. But hundreds of thousands is certainly something that we've measured. So we're trying to get towards millions, but.
I've got two quick questions for you. First of all, in your example of importing the PCAP file and an EVTX file, do you have any features in there to adjust for clock skew?
Yes.
Yeah, we do. We have the ability to manually go in and adjust it. So for each file, you can specify a relative offset for that entire file.
Okay. So again, careful that you don't do that and influence yourself to make the clock adjust to what you want it. I was thinking about exactly that before, but okay, so we can adjust for clock skew. And the next one was your operations groupings. Is there a list of criteria used to establish those groupings? As if there are things that are not necessarily related to what you're looking for, that might just muddy the waters, or there might be some things that are included in there that I don't expect or I don't understand why they're there.
So in terms of operations, those are done as models. So basically, that's very well defined. So HTTP, for example, looks for an HTTP GET followed by an HTTP response on the same port, and it groups those as an HTTP operation. So where we've put them in, they're very well defined. If you define patterns as sequence expressions, that's up to you. It can be as coarse or as fine-grained as you want.
Yeah, and other thing that I didn't show is that you can also choose the viewpoint that you want to look the traffic at. So for now, I just use the top viewpoint. That is, I'm seeing everything from the highest possible perspective. But if you are not interested at a particular level and you want to drill down a little bit, let's say that you are also interested in diagnosing TCP, you can choose your viewpoint to be TCP, and that means that the upper layer traffic will be hidden, and that also includes operations.
So I've got one last question. I missed the first 5 minutes of the talk. Can I apply this to servers? Are there any restrictions?
No restriction.
No restriction. Perfect.
Yeah, there's a bunch of very interesting data pivoting features that we didn't show. So we showed multi-level grouping. You can make selections, swap your grouping around, and the selection is maintained, but all the data is pivoted differently dynamically. We also, as you're changing your viewpoint, we know the full history, and so some of the views will show that. So if you're looking at TCP and you select a particular message, there's one window which will show you the entire protocol stack for that message, and it shows it to you in the full context of everything that it knows about that message. Even though your viewpoint is TCP, it might show you you're up in some POX protocol. Other questions? Yes, we do have a parser for IIS logs predefined. You could write your own as well.
And then one more over here. Go ahead.
The sequence matching thing, do you have the ability to import IDS signatures, like smart signatures into that yet?
We don't currently. We've looked at the languages, and I believe that we can support everything. There's a equivalence mapping, but we don't have a automatic translation tool for that yet.
Chris and Serge, thank you. Appreciate it.
Thank you.